Welcome. In this video, we'll continue the study of the application of derivatives, and you'll solve another example in which you are going to find the monotony of the function, which means where the function is increasing or decreasing, and also we're going to find the extreme values of a function, the maximum and the minimum value of that function. So our function is f of x is equal to x squared minus 3x plus 2. So to find the monotony, or to study this function, find the monotony and the extreme values, we have to go through three propositions. The first one is f dash of x should be equal to 0. If f dash of x is greater than 0, then the function is increasing, and if f dash of x is less than 0, then our function is decreasing. So first we have to check all these propositions one by one and going downwards. To verify the first proposition, we have to find the derivative of that function first. So we have f of x is equal to x squared minus 3x squared plus 2, and this can also be written as minus 2x squared plus 2. The derivative of this is minus 4x. To apply this, we have to equate this to 0. So we have minus 4x is equal to 0. So we have that our x is equal to 0. This x is equal to 0 is called critical point. This is called critical point. So what it means is that in the x-axis, consider this as an x-axis, the values go from minus infinity to plus infinity. We have this point here, which is a point in which the function is more likely to have a maximum or a minimum value, which means extreme value. So we have this first interval, which is the part before the function reaches to the critical point, and then the function will remain in the critical point, and afterward the function will continue to the plus infinity starting from the critical point. So to represent that ranges of x, we write x in this row, we have f dash of x in this one, and we have f of x in this one. So the first interval, which is this one, to represent it, we just say for x belongs from minus infinity, belongs to an interval from minus infinity to 0, stays in 0, and then from 0 x goes to plus infinity, which is this second interval. Now what we have to do is to find whether this f dash of x is positive or negative in these two intervals that we have here. And to find whether it is positive or negative, we have to choose any value in that interval. So I can choose minus 1 here and 1 here for each interval. Testing for the first interval will be minus 1. So if I replace in this function here, in this derivative, I replace f of dash, all the places I have x, by minus 1, I have to check if it is going to continue to be positive, it's going to continue to be negative, or it's going to be positive. So I will have f of minus 1 is equal to minus 4 into minus 1. This is equal to 4, and 4 is positive. And then I say this function is increasing. The second interval, I've chosen 1. So f of 1 is equal to minus 4 into 1. This is equal to minus 4. Minus 4 is negative, so the function is negative here. Now we have to check for these propositions. If f dash of x is greater or equal to 0, the function is increasing. F dash of x was positive, was 4, and 4 is greater or equal to 0. It's greater than 0, I mean. So the function here is increasing. And here it was minus 4, which is less than 0, which was this condition. As you can see here, this function was increasing and then started decreasing. So we have a maximum value, because if something is increasing then decreases because it's reached a maximum value. So we have a maximum value. So we have to find what is the maximum value of this function and this critical point. So to find the maximum value of this function, what we do is we take the value of the critical point and then we replace it on the given original function. So critical point is 0, we have to replace in the original function. So we have f of 2 is equal to, we have here minus 2 into 0 square, this is f of 0 because our critical point is 0, plus 2, so this becomes 2. So our maximum point of this function, the maximum value of this function is 2.